Hey guys, it's Landon from RH. In this video, I'm going to demonstrate to you a tool I built in Python. It's called Comparatio Naturalis. So it is a tool that lets you select two different documents, basically either plain text documents or what we call markdown documents. And it allows you to select an on-disk or a local large language model. So it's a GGUF file. You can pick any model you want. You set some parameters, and then it'll give you a natural language summary of the changes between the two documents. So if you come from a programming background, you might be familiar with what they call a diff file. That's where you compare two source code files and you get a summary of the, you get a, I don't know if you would call it a summary. You get a textual description of the changes. This is like a human readable version of a diff file. So let me explain why I wrote the tool, and then we're going to see if it works. I've never tried this. Is a brand new tool. I've never tried it. So why did I write the tool? I'm actually working on a separate tool that analyzes Python code bases and provides a report on different types of code quality. And I'll do some videos about that tool in the future. But I needed just a really simple code base to test that tool with, and so I wanted to just kind of I needed a program I could just whip up in a couple hours vibe coding, and I've been wanting to. I do a lot with large language models, and I use LLM Studio, which lets you interact with large language models that are on disk. But I've been super excited about the potential of integrating large language model capabilities into my own Python programs. And there's some libraries you can use to do that. I'm using one that's called LangChain, L-A-N-G, LangChain. And I'm super excited because there's all kinds of potential for that. I'm super pumped. And so that's why I wrote this little sample program. I wanted to try that out. I said, let me see if I can write a Python program that uses LangChain and puts natural language processing via large language model, puts those capabilities into a desktop Python program. So that's what we've got here. So we're going to try this out. I've never used it. This is either going to explode and send Python shrapnel all over my desktop computer, or it's going to work and I'll probably have a heart attack and fall out of my chair. Okay, so I've selected the old version of the document, and then I've selected the new version. And just so you know, we did some training. We had our fantastic First Friday training day here at RH, and we talked a little bit about monument preservation and why monument preservation doesn't happen and why our utility company clients don't really care. That it's done properly. They just want to get their permit, and it's not because they're evil. It's just because we're dealing with what they call an externality in economics, and that's the way the incentives are set up. And then we talked about, what happens when the local government regulator isn't doing their job. And anyways, we had a long conversation. So what I did was I got a sterilized version of that because I talked bad about some people in the original version, mostly local government agencies that aren't doing their job. And that's not something I want to put out all over the internet. Despite my reputation as a troublemaker and a hothead, I try and be a little more discreet than that. So this is a sanitized version. And in this version, I talked about records of survey and why surveyors don't follow records of survey and how that's another externality that's, the government has to enforce and they don't necessarily do a good job of it. And so I wanted to strip out all that conversation. I wanted just a white paper on the economic incentives and flaws with monument preservation that I could share online. So that's what the second version is. So I browsed to both of those. I've selected my large language model here on disk. So this is Gemma. It's a basically condensed model that Google Gemini uses. It's a condensed version of the model you use when you interact with Google Gemini on the web. There's some model parameters here you can tweak. And then we're going to hit summarize changes here, and we'll see what we get. This is a little taskbar down at the bottom. if you're wondering what's in the background there, that's Windsurf IDE. That's the integrated development environment that I used to do my vibe coding. You'll notice this is a nice looking user interface on a grid layout. That's because I'm using TTK, TTK Bootstrap, which is a library that pretties up Tkinter interface. It's like makeup for Tkinter. Basically, it's mascara and foundation for Tkinter. So, all right, you ready? I'm so scared. I have no idea what's going to happen. It blew up. It says failed to load model. Could not import library. Please install the Python library to use this model. Okay, so maybe it just doesn't like our model. Okay, guys, I finally got this thing working. It's the next day. So it took me 2 or 3 hours to troubleshoot off and on, even with my vibe coding tool. Make a long story short, there isn't a great way to use a large language model directly from Python. So what I ended up doing is I ended up installing a tool called Ollama and using that to kind of bridge the gap between native code and Python for the large language model. So I'm just going to pull up the web page so you guys can see that. It's a cool little tool. It's the best solution. I looked at some different solutions. I actually put together a little guide for developers that might be trying to integrate LLMs into their own Python program. So I'll try and get that online. But here it is, Ollama. So you have to download this to get the app to work. What I'll probably do is I'll distribute my app with a copy of the Ollama executable to make it easy with a little guide and a video on how to do that. So anyways, that was the solution. So my Python program is actually communicating to Ollama under the hood. So Ollama has to be installed on the Windows computer. So I've got my 2 documents loaded here. My version of the 2 versions of the same document, basically talking about survey monument preservation. I picked up a model here. I've just decided to use Gemma, but you can browse for different models as long as they're supported by Ollama. They'll work. And then you can set your model parameters here. I haven't messed around with that very much. And then you just click Summarize Changes. So I'll do that. We're going to get the summary results here. Now this takes a little while because the large language model is running on your local hardware. So it's not as fast as what you get with a web interface like ChatGPT. But you can see it's starting to work here. Okay guys, so it's finished here. So you can see I've got my summary. I don't like that it's right in the first person. That might be, I thought I fixed that. That might just be the way the model is handling the request. But it gives us a bullet list here in Markdown format, so we can actually export that. So we're going to just call this doc. So we'll save that. Let's go ahead and open it just in Typora so you guys can see what that looks like. Switch to one of the themes I like. Alright, so here you go. Here's the difference. So you can just clean that up. Here's your bullet list. So that's just a quick summary of the difference of the documents. Now, that doesn't seem earth-shattering, but you can imagine if you had, a couple documents that were 20 pages or 40 pages or 50 pages, having a summary like this is pretty helpful. You could even tweak the prompt to provide the heading that contain the, Markdown documents don't really have pages, but you could get the heading or the line number of the change. So that would be fairly easy to implement. Now, in this particular example I've got here, the output of the large language model is just being shown, and you're able to save it. But I want you to understand, so under the hood here, we're sending the two Markdown documents and a standard prompt to the model. And then we're just displaying the output that the model gives us, which is a natural language summary of the differences in the two documents. But what we could do is we could just take that output from the model and just use it directly in the program. And that's probably what most Python programs with this capability will do. So as an example, I got some tools that convert bearing and distances into coordinate listings and then closed polygons for a DXF file. The idea there is they can be used to automate decogo. What I can do now is add a graphical tool, a GUI tool to that tool chain where you upload a text file of your legal description or land description from your deed, and you can pass it to a large language model, under the hood. In other words, not visible to the user, and you can just get the output file that goes directly into the next tool in the chain. Right, so you can automate that process. That's probably the first thing I'll do now that I have this capability figured out, so that my people will be able to do that. Right now you got to extract the text content, go to a web interface for a large language model, upload it, try and get the right output, give it an example of the type of output you need. So I can automate a lot of that. Can happen under the hood now. So this is cool. I'm excited about it. You can see the local models, don't run super fast, even on this is a good laptop. This is a $5,000 laptop. But, we have some capabilities here now with natural language processing on a local hard disk that we didn't have before. You can incorporate that into your Python programs. And this avoids a lot of the security issues and some of the other concerns about passing sensitive data to the web. This can all work on disk. I'm excited. Hopefully this gives you guys an example. I've been thinking about it, and I think I'm going to expand. I'll build on this tool a little bit over the next few weeks. I'll add that ability to get some information about the location of the changes, and maybe we'll tweak this a little bit to where you can get some more detailed information on each particular change. Maybe with the old content and the changed content, side by side. I think I'm going to give users the option to customize the prompt a little bit that's sent to the large language model. So we'll have a little edit prompt button here. Maybe we'll have a little button where they can browse for example output, so the LLM can format the output the way they want. I'm excited about it. This is cool. I'm super stoked I got this to work. Thanks for hanging in there and watching it. I will get that guide for other Python programmers online as soon as I can. It kind of explains the challenges I ran into trying to do this and how I fixed it.